All right. Welcome, everyone. Welcome to Tines and Greenlight, our first webinar in a new series that we're calling Tech Talk. In this series, we're going to talk with customers about how they're using Tines, what challenges they were facing, and how they solved them. And we'll get to see some of the workflows and examples of how they did that. So, quick introduction. I'm your host for the call today. My name is Beth Gage. I have the Worldwide Solutions Engineering team, and we get to work with folks like Greenlight as they're getting to know Tines and getting to learn more about us. And today we have Max and June from Greenlight. Max, June, do you guys want to do a brief introduction and tell us a little bit about yourselves?
Sure. I'll start. My name is Max. I'm staff security engineer here at Greenlight. I've got an offensive security background, and I really found my interest in AppSec specifically because of all the complexity that happens with all the engineering work, partnerships you get to build with people across the org. So that made it a lot of fun. But throughout my kind of background, many of the critical issues that I found, especially where you find breaches possible from an AppSec related standpoint, these were typically due to really easy to exploit vulnerabilities. So as I moved to Greenlight, kind of the biggest thing I wanted to learn was how to build processes and practices so that we could systemically reduce this type of risk across the organization.
Hi, my name is June Pham. I've been at Greenlight for about two years. Next month is going to be my 2 years mark. I am staff security engineer working with Max on product security. Before Greenlight, I worked at Visa on the mobile security team, focusing on doing penetration testing on like the Visa mobile applications as well as the vendor mobile applications. And before that, I had some background in penetration testing on web application and mobile application at another company. And so just like Max, I'm very excited to learn more about like the processes. How do we build an effective program for product security?
Awesome. Thank you both. So, folks, as we go through the webinar today, we're happy to take your questions as you have them. We'll also leave some time at the end for your questions as for Q&A as well. So if you do have questions, please put them in the chat window and we'll get to them when we can. So today we have a very straightforward agenda. We're going to start with just a brief introduction to Greenlight and the problems that they were facing with vulnerability management. We'll talk a little bit about why they chose Tines and then start diving into their solution and understanding the value that that brings to Greenlight. So with that, Greenlight itself. I know about Greenlight because I've been a customer on the personal front for a number of years with my daughters learning how to manage money. But Max, would you like to tell a little bit more about Greenlight and the company itself?
Yeah, absolutely. Greenlight's kind of main goal here is to help families learn how to manage money. I think it's a big challenge for anybody, regardless of your age. And I'm really happy that our mission is kind of focused around families and kids as well, because I think that's kind of the earliest time to start. But really here, our goal is to help families earn, save, spend wisely, and also invest together. So you can do all that within an application. We have both iOS and Android application. We do pretty decent on the App Store. And then we also serve a lot of families and work with banking partners so that we can better serve Greenlight.
Awesome. So let's level set for everyone joining. I know some folks that are joining are going to be in vulnerability management teams like yourselves, but others may not. So Max, you want to take us kind of through the high level life cycle of vulnerabilities and how you guys look at it?
Yeah, definitely. So this kind of accounts for all of the vulnerabilities that come into our organization as a whole. So to kind of walk you through it, some new thing pops up, whether it's from a tool or it's a manual finding or somebody has found a problem, right? At this point, we're kind of triaging, trying to figure out where that goes. And then once we've kind of identified, what is the level of priority here, we have to start to assign this issue. And then we have to go and kind of find out who owns it. Sometimes that can be a real pain in the butt, really, especially trying to figure out who that goes to, who needs to fix it. And from there, we try to figure out, okay, is this something we need to solve today? Is this something that we already have in progress that we need to start actioning on? There might be discussions around risk in this area. And then as we kind of move forward, let's say all things happy dandy, things go well. we say, hey, it's fixed. Maybe we upgraded some dependency, or maybe we've removed some hard-coded secret from our code. From here, oftentimes we might see engineering teams happen to just close the issue and we say, okay, cool, it's done. I think that's kind of the first baseline of maturity to start with. And then as we've kind of grown, we were like, all right, well, we need to also retest it and make sure it really is done, right? Sometimes we have to reopen an issue because it wasn't confirmed to be closed as we thought it was. And then if it is actually verified, we can actually keep it closed. So it kind of gets a little complicated when it comes to vulnerability management or its life cycle, depending on where it comes from and how to test it.
Okay, great. Well, with that, why don't you talk us through some of the challenges that your team was facing?
Yeah, so when we first started with vulnerability management, I think one of the first things that we fell into, that I think a lot of organizations that I've chatted to also kind of fall into this trap as well, is that they're trying to figure out, how do I find everything, right? How do I find all these problems? So as we did that, you want to expand coverage, and that can be a tricky situation. So as we expand coverage, the first thing that we found is now we have different data sources coming in as to what is going to be considered a vulnerability to our organization. The next thing is figuring out if we have custom checks that we do for it, because maybe we didn't have the funding at the time to purchase a specific type of tooling. So we need to go a different homegrown route or open source route to do that. And then as we do that, you can imagine we also change tools as we realize it's a problem that might need an enterprise solution. And then so I guess as we kind of move forward into this, right, the next thing is that you have this huge volume of issues being produced by all your tools, whether it's custom scans or anything like that. A big culprit, I'd say, are high false positive rates that are coming from software composition analysis and your static application security testing tools. So that's something that we, one of those first challenges that we also had to deal with, that was manual tool for us. And then as we move into the next piece here, what we found was that a lot of the tools that we were leveraging, especially in the industry today, is that they're very tool specific for policy wise. So if you want to set a priority for a certain thing because that's how your system works, or you want to claim that something is more important or less important, a service is more critical, each one of these tools require their own special tuning to do so. So that made it very difficult for us to have to manage, go into every single tool and handle that situation, especially during onboarding, because these tools simply just don't have the context of what's actually running and what we know is important to the business. And so that resulted in a lot of back and forth with our engineering teams too, which is not great for building partnerships. So that's one of the problems we wanted to solve for. And as we kind of went through this, the other way is kind of go, all right, let's go sit in the background and do a lot of manual triage ourselves. But another problem that comes in with our organization is that we have a pretty lean product security team. There's not too many members. We're not super hugely staffed either. So a lot of manual triage time was spent originally to adjust severity levels for things. And then we had to account for what security controls we did have in place, whether we had documentation for it, or we just know it because we've tested it, or we've seen it on our pen test results, or have done it ourselves. And also identifying the right owners, especially as organization changes. People get promoted, people leave or come in. You also have new owners coming in and out. So that makes it difficult too. And then finally into the next piece here was, once we had all these findings, and let's say you did all this magical work and all this hard work of finding out who it belongs to and fixing things and getting the right priority, then you have to go and verify that those things are actually fixed. So that in the beginning, when you first bring on tools, that often just looks like, okay, I'm going to go look at the tool, validate if that's there or not. But if you have a huge volume of issues, you're constantly going back in there week after week, and really likely to make some sort of human error at some point.
So you mentioned that you had a small team. How many, or roughly how many of you were focused on the vulnerability management aspects in these challenges?
Yeah, so we have right now in our product security domain, we have about 3 people. Actually, not about, exactly okay. 3 people. And then so 2 of us were focused purely just on the vul management stuff. And that takes a time away a lot from us when it comes to helping out on actually building security controls and security reviews, like architectural reviews, and providing that type of more hands-on service to our organization.
Okay.
To talk a little bit about our vulnerability input sources, specifically here, I'm going to chat about the ones that are specifically with tines. Reason why is that these are going to be product-related vulnerabilities. So things also that are not included on here, like pen testings or things that are found from manual testing, as those don't have an automated input source. or bug bounty, for example. But our SAST findings that we've kind of talked about a little bit before with all the code scanning that's happening, like looking at code syntaxing, any type of weird code smells going on. Right now we're using CodeQL to help us with that. And we have some specialized queries that help us to identify potential issues. So that, is one of our input sources that can take some time to verify. As we move into the next piece, we were using previously some static software composition analysis, but we've recently started working with Oligo for runtime software composition analysis that tells us a little bit more information about reachability, so we can kind of get into how we leverage that within our organization. And that helps us to tell us which of those dependency issues are actually important to work on. And then moving into that, we have secret scanning from GitHub Advanced Security. And then finally, we have some Docker file scanning that we handle from a custom timed story. And that essentially is kind of a custom analyzer that we are taking a look at certain base images, making sure they're adhering to a policy that we have and things of that nature.
So just curious, from a volume perspective, what was your largest volume here on the input sources?
Yeah, so previously when we were working using Dependabot, Dependabot gave us about 4,000 issues that we were supposed to be working on and supposed to be important to our organization. So I think a big challenge for us not only was the ownership of those, because we still want to identify who the right owner is, but for us it really came down to figuring out what the priority is. So as we kind of get deeper into it, we can kind of share a little more detail on how we figure out which one is important for us. Okay,
great. Well, let's transition over here to your core principles and how you approached it.
Yeah. So the first core principle that we had, so as June and I got together and tried to figure out, hey, we have a huge problem on our hands. We have the ability to find problems right now, but we don't have the ability to actually solve them very effectively. So the first thing that we kind of brainstormed is that a simple approach is the best approach, something that everyone can understand as to why we're giving a certain priority and why we're bidding it to be a certain way. And really that is because that makes it easy to explain. And if we need to adjust, we can adjust. But from there, it's much easier to evolve and share that logic with everyone else. The next one is that we really want to focus on what matters. So we have as we kind of build out new vulnerability input sources and consider what's important to us, we actually have kind of a specialized approach that we kind of do things with rollout in terms of what we care about for the organization. Because the fact of the matter is, beyond security alone, there are a lot of things the organization needs to get done, right, in order to keep the business running. So we really aim to be an enabler for our business and making sure that we're not taking time away from developers on things that are they nice to have? Absolutely nice to have, but if they're not mission critical for our security, those are things that we need to segment out specific time for, accordingly to our business priorities. And the next thing is that automation was a big key for us as we kind of went through this manual process for maybe a month or so. At that point, I was tired of clicking on buttons. And so consistency was the best way through automation. It was the best way that we could make that happen because if there's a mistake or something like that, it's much easier to go into a configuration file and modify who's the owner and then say, hey, okay, now we fixed it, as opposed to going through every single ticket that we have and manually checking those. And then finally, for us, what we care about is that we actually make progress. I think a lot of security teams that I've kind of chatted to, as they work through vulnerability management, a really common approach is to say, hey, let's start all critical and high issues and just throw them at the wall and see if it works. Typically, it doesn't seem to work because that's a goal to get at, right? It's not something that we can just say, hey, let's throw them all and see and cross our fingers. For us, we want to make incremental progress over time, and we really did leverage automation in order to make that happen.
Great.
Cool. As we kind of get into our goals here, the first one is that we wanted a consistent single process. So for us, that meant identifying who is the assignee of a certain issue that we need to resolve, defining the SLA times, making sure that's all set up and happy dandy, tracking to make sure the priorities, tracking to make sure the progress is there, priority, the formatting of the tickets for depending on where they came from, all those sorts of things. We wanted to make sure no matter what input source it came in from, especially like closing out issues and things like that, that was one thing that we could modify from a single configuration. And then the next piece is for maintenance. For us, a really big issue is because, again, as we are a kind of lean team here, when it comes to changing out how our tools work and what the output is, we want to make sure that as our maturity evolves and we want to add additional coverage and things of that nature, that it's not so cumbersome to do so. And it's not going to take us like 2 weeks just to get something done like that.
Yeah.
And then finally, when we're updating our tools, and tools specifically when it comes to our vulnerability input sources, we often were looking at like the integrations of those specific, security testing tools or scanning tools on whether they had specific JIRA integrations, for example, in our organization, and making sure that they were adequate, right? For us now, because of this, you can programmatically, as long as there's an API available to capture that information, even if it's not super mature, you can either do some post-processing to make that information something that you can easily handle within some sort of automation.
Before we go to the next slide, just with respect to your goals here, the single process goal in particular, do you have like a rough ballpark of how many processes you were dealing with in the before scenario?
Yeah, for each
tens of.
Yeah, I would say for each one of those vulnerability input sources, we had a separate process to handle each one of those types of findings. So it'd probably be maybe like 4 different things that we had to kind of click through and figure out, okay, what's important here, when we're still following very similar practices, as in looking for who is the right owner, trying to figure out what the priority of that is and things like that.
Yeah. And then on the maintenance and the before scenario, like, do you have a rough feel for how much of y'all's time was spent in maintenance activities?
For maintenance activities, I'd probably say every month we probably used to spend maybe like 10 hours or so just trying to figure out like some sort of bug issue that we have, whether it was pre-times when we were working with our own automations to see what was going on. And we had a couple of challenges when it came to, for example, let's say somebody is out and maybe they own the maintenance of the automation. It sometimes became a little hard to figure out what exactly was going on if we didn't have that context.
Right. Yep. Makes sense. All right.
Cool. And then as we kind of figured out what our solution is, hopefully you guys can't hear the leaf blower too much going on outside here.
That's what happens.
But our goal was really to build an automated and an effective vulnerability management program. And effective here in our definition means to make progress in some way. And I think we lost the slides.
Yeah, I don't see it either.
All right, we'll just hold off a little bit until we get Beth back here. I think there may have been maybe some connection issue. Oh, so it looks like we have a question on what's our favorite thing about Tines. I can take this one for now. For us, one of our kind of big favorite things that we really enjoyed about it was that kind of talking about the previous, content that we were just chatting about when it came to change of ownership and things of that nature. For us, when a new person has come in, it makes it a lot easier to walk them through what our vulnerability management lifecycle looks like, because it's more graphical as opposed to purely based on code that sometimes doesn't have all the comments that you want it to have.
Yeah, so we have another question that we can answer in the meantime. Can you describe how long it took you to create the custom story? So it depends on the custom story itself, as well as the goal that we're trying to achieve. But most of the time, right, when we have established a story that is for our consistent process, when it comes to like swapping tools in and out, it would probably take like a couple of days to create like the story and making sure that it is fully QA tested and that we're seeing the result that we're expected. So this is like a huge reduction in the time, because it used to take a lot longer than just a few days, but now we can roll out like a change in process in terms of tools in just a few days.
And to add to that, part of that few days is also testing to make sure it works right.
Yeah.
Cool. All right.
Okay.
So back on to this one. I can take it from here. When it comes to our solution, one of the big things, kind of the steps that we wanted to make sure that we had from our automation is the first thing is we wanted to be able to intake several different types of vulnerability input sources. Manually, that took a couple hours a week. It's not very fun to be clicking on buttons on different platforms, making sure that we're looking at the right things, have the right filters and all that stuff. The second thing was that we wanted to make sure that we were applying a global policy through our prioritization engine, which we'll kind of get into more details as well about at a high level how that kind of operates for us. The reason why it would take so much time is we'd have a huge volume of findings, and a big one for us, again, is kind of the SCA issues. I'm sure that many of you who may work in vulnerability management specifically right now, especially with the software side, you'll see a lot of those types of problems where I think a lot of organizations that I've chatted to as well, they kind of just put their hands up in the air and say, I give up. This is not something I can handle. So that's kind of one of the approaches that we've taken with it, and we'll kind of get into detail. And then next is we want to be able to create JIRA tickets. JIRA is not the most friendly when it comes to creating tickets manually. So it's not something we spent a lot of, or we were very happy spending a lot of time with. But this is for our organization, we're very ticket driven, and we wanted to make sure that we were able to meet that workflow as well. And then for assignment of tickets, we had some challenges when it came to finding out who owns what. There are some organizational issues when it comes to making sure your organization has a clear definition of who is the right owner for specific assets. So I'd say that's a prerequisite to really make this thing happen. And it's a partnership that we've built with our engineering department to make sure that we had the adequate information as they did as well for things like maybe potential incidents as kind of that linkage point between the two. And then finally, we wanted to be able to make sure that we could close issues once we know the remediation has been completed. So for a lot of our static tools, that's a pretty pointed solution as to knowing whether or not something is done or not. And then as we kind of thought about our solution options, the first one that we actually went with was manual. So we first started manual because we got some tools in place and we had to start doing something, right? You start finding problems and you want to make some progress. So for us, when we were looking at this, manual quickly became a non-option because it was super time consuming, and it was also really inconsistent because things will happen throughout your day and you just don't have the time to be able to create those tickets or even evaluate whether or not an issue is important. So the next option that we also looked at here was for a locally run Python script. So we made some really quick and dirty Python scripts. But the problem here is that as we had new members come into the team, or we had ownership changes for the script itself, we had challenges maintaining it. Also, all the kind of local dependencies you might have to run something, all the API keys and things like that. That became also a problem pretty quickly as well. And then the next option that we had considered that we never really went full with was that we were planning to go with some scheduled runs of just some Python script that runs on an internal server, but on top of all the other things that you kind of see previously that you can imagine come with that is also the infrastructure maintenance. So for us, that's just for what we were looking for. We simply just didn't want to deal with that extra headspace when all we wanted to do was to create tickets and make sure the ones that we are providing are actually useful for our teams. So finally, yeah, when we went into Times, when we heard about Times, it was pretty exciting for us because all those issues are kind of gone when it comes to what we've chatted about. Of course, you still have to create your own automations and tailor it in that way, so it doesn't solve that part for you. But in terms of all these kind of other issues, when we're looking at, I see there's a question here for what requirements did Times satisfy when we're looking for a security automation platform. For us, it really came down to making sure that we could solve the issue of having a consistent output no matter who is working on it. We have an easy way to understand things. And then we'll also get into kind of a little bit more details on how we evaluated that too.
Yeah, that consistency is golden, right? Especially if you have team members coming in and off the team and just the same process every time.
Yeah, absolutely.
Yeah. Thanks, Max, for walking over like the solution. So I'll talk a little bit more about like why Tines for our automation. So first of all, there's no infrastructure to manage. You can just create a Tines story and then have it scheduled to run once a day or once a week or however often that you want it to run. So there's absolutely nothing to maintain in terms of infrastructure. The second reason is that it can withstand staffing changes. So whether it is from the security team, it's very easy to maintain. Someone new coming in can just pick up, our automation. Same with like the ownership for the tickets, right? So we also have automation that is helping with the staffing changes in engineering as well. The third reason, I feel like there's so many reasons for Tines, but the third one is that it is reduce barrier to entry. So Tines is like very graphical. It's very easy to understand. Of course, you would still need to understand some basics when it comes to computer science, like which API to call from your tool, how are you structuring that call. But in general, is a lot easier than if you are going to write the whole script yourself, or if you're inheriting a script from someone and trying to understand what that means. The fourth reason is that it is very easily customizable. So Tines, so if you explore Tines, Tines has like some functionality for, say, calling HTTP requests that you can just plug in like the URL, like the authorization token, and set it up to how your company's requirement is, as well as other, like UI functionalities that is very easy to just drag and drop in, and then you have a story. And then the last reason, I think there's one more, or is, okay, perfect. So when it comes to the time solution that we're writing, there are some of the design considerations that are specific to the Greenlight system. So the first one, as Max mentioned, right? So every single tool, it does not have the context as to what is important for your business. What do you want to prioritize? So in order for the tool input sources to fit into our system, we have to make sure that everything goes through a single system, that every single tool is receiving the same context as to what are the priority, who to assign it to, things like that. So when you imagine that an SCA tool, for example, that outputs like thousands of critical issue, then at that point it means that nothing is really critical, because you're looking at like a large volume of things that are supposedly you need to take care of immediately. So Tines really help us, like wean down the noise, and making sure that, like tools got the same context as to what is important to Greenlight. This is also helping, with like adding or like changing tools very easily, because at this point you have a single process that you can just plug and play the tools with. So the next consideration that we want to look at is the ownership. So every single vulnerability has to have an ownership, because as the security team, we don't have the context of the code. Even though we would like to, we cannot fix the vulnerability themselves. It has to go with the engineering teams. And so in that sense, right, like staffing change all the time. People come, people leave, people get promoted all the time. And so so the person that is assigned to the ticket might not be accurate. And so this is, so the impact of this is that it might disrupt the SLA, or like the due date that you would want to set for each of the finding. So depending on the risk tolerance of your company, right, like you might want to set something high to be fixed within 30 days, something medium to be fixed within like 180 days, things like that. So when you have those SLA and you have, like the ownership disrupted, it would be hard to guarantee that every single finding would be fixed within the SLA. And so Tines is a solution that is helping us with that. Another thing that I want to note in here is that the way we're solving it with Greenlight is that we're using the code owners, which is like a built-in file GitHub. So this is a perfect example of like how when you talk to like people in the industry, they are saying that you should align your security process with other processes in engineering. And so this process has been backed and supported well loved by, you know, the rest of the Greenlight and engineering. And so what security is doing is that we're just tagging along with the process. We're not inventing anything new. And it is very well received by everyone, and it's great for building partnership as well.
Great.
Yeah. And then the last design considerations that we want to take into consideration is implementation error. When you're dealing with like a large volumes of findings from the input sources, errors tend to happen. You know, it might be the mistake of the human, it might be the mistake of the tools. You know, so we have to have a way to make sure that we're limiting those errors as much as we can. And so when it comes to the ticket, right, so whenever we're rolling out a new tools or like a new class of vulnerability, we want to make sure that we're reviewing the ticket, making sure that the description is clear, making sure that it is actionable, making sure that the owners are there. So our solution is to roll out this issue onto a sandbox space before we roll it to production. And so Tines help a lot with this, right? Like we can just click an automation to roll it out to sandbox. It looks good. Now we roll it to production, as versus to doing it manually, which is definitely not fun. So this has been great.
A question that came in from the audience here is, how have you found managing updates or changes to APIs for tools within the stories? Is that something that you guys have run into a lot?
So we have not run into this issue too much. Most of the time, the APIs from the tools are pretty stable. But you know, it did come up, you know, like once or twice. So in those cases, you know, it's pretty obvious that, you know, like the times our automation is failing. Is that I mean, mainly because the API call to the tooling is not successful. So in those cases, it's pretty obvious, you know, like when you look at times. And of course, like there has to be some alerting system to make sure that, you know, like the tools are running as expected. And also partnership with like the vendors that you're working with also help as well.
And then to add to that one too, we did have a kind of like recent case where it wasn't specifically an API change, but it was like a token expiration, right? And then so what we found was that the automation showed a bunch of red marks, and then we know, okay, it's not working, right? In terms of maturing this is definitely something that's on our list. It's not a huge priority for us right now because we can kind of go back in there. It's not the best way to do it, right? But the next thing that we'll have in there is just for a trigger that's just checking like if we are getting, for example, a certain type of error message from the HTTP response or an empty body, you know, at least we can send a Slack message or an email back to us that says that we need to check something.
Yeah, great. All right. So June, I think you're going to show us the story.
Yeah, absolutely.
All right.
Okay, so I will show you one of our stories. This is for the SAS and the secret, the hard-coded secret findings. So for both SAS and hard-coded secret, we're using the same tool. So you're seeing them in like, so you're seeing two tools in the same story. And the reason for that is because you know, like the vendor might have a rate limit on like the number of APIs that you can call per day. So it's up to you to like design how the story would be. But in our case, because of the rate limit, we figured that if we combine them together, because they would share a lot of like the similar steps, like you're calling to every single repos, you're looking at like the issues in each repos. So for these two tool sources, they both come from the same tool, so it might make more sense to combine them together, as versus if you have like, you know, different tools, it might make sense to have each story for each of the tool. So so this is the SAS tool, right? So we have like a schedule that runs this tool every single day at a particular hour. Essentially, it is looping through every single repos on GitHub. This is a GitHub Advanced Security, by the way, for code QL and for secret scanning. And so we essentially have a for loop. So this is where you can see that it's very intuitive, just looking at the code, that this is a for loop, making sure that we're getting every single repos from GitHub. And, if the repo is not archived, then we have some other filter. We extract the owner's team and owner's domain. So you see this one as one step, but it's actually like a whole other story that we have to make sure that we can identify and assign the tickets to the correct owner. So it's, very modular. You can write the story once, and then you can use it in every other flows and other stories. So if once we identify an owner's team, we split out into two different input sources. So one is for the SAS, this is for code QL, and then the other one is for the secret scanning. So for the secret scanning, right, once you are in the repo itself, you loop through every single alert or the finding from secret scanning. And if there are any, then you're creating a new issue in Jira. And so I can show you how we're creating it in Jira as well. So as you can see, it's a whole other story that we just kind of plug and play into the master story, right? So you can see that, we're checking if the alert is still open on GitHub, then we're creating an issue in Jira. And so at this point, we're going back to our Jira space to see if it existed already. So as you can see that, with times, this step probably takes a fraction of a second, but for a security person to come in and validate whether this exists or not in the Jira board itself, it might take several minutes for each of the findings. So that adds up really quickly. And after that, right, we know that it doesn't exist yet, then we are assigning a priority, an SLA that makes sense to our organization. And then we're creating a Jira ticket for that. And so as you can see, everything is highly automated. It's very plug and play. Another thing that I want to talk a little bit when it comes to the life cycle of a vulnerability, right? The last step where the team said that it has been fixed. So now if we want to verify whether it has been fixed or not, for automated tools, it's very easy. All you need to do is to go back to the tool source and look at that particular finding, see if it's still existing or not. So if you are doing this task manually, it takes a long time. But if we're doing it with times, you can just combine it in one story, and then making sure that it has been closed. Then you would sync it up with Jira. So this actually helps a lot, both way with the security team as well as the engineering team, is that we're building trust that the engineering team is saying that it has been fixed. Then we know for sure that it has been fixed. Another thing is that if the team fixed the issue, but they forgot to close the ticket, what might happen is that the ticket might exist forever, go out of SLA, and then our metrics is all messed up. We lost track of which one is fixed, what is the real time to remediate. And essentially, we lost track of what is important for the security team to focus our effort on. So this is a great help from times that we're able to verify whether an issue has been fixed or not.
Awesome, great. And then just to make sure, clarify here, this story handles all 4 of the input sources?
This story handles 2 of the input sources.
2 of them.
Yeah, correct. And the reason why they're combined together is because they are different offerings from the same product. So it makes sense, to combine them together because they share a lot of steps together. Like, for example, when you call in the API to the tool itself to get the repos, each of the repos, right? So the 2 input sources share all these steps. So it would make sense to just run it once. And then another thing is that the tool also have rate limit for how many times you can call the API in 1 hour. So by combining it, it would save a lot of time, and it
Right.
help us from not being locked out.
Yeah. Okay. That makes sense.
And we do have some plans to consolidate our store usage. So we are working with Tines on that, just for anyone who's wondering.
Okay, great. Thank you for sharing that. I'll head back to the slides here.
Yeah,
So,
absolutely.
yeah, June, you were going to tell us about how the engine that you built for the prioritization.
Yeah, absolutely. So this is the context of business as to what is important, as to like helping what is important to Greenlight, right? Because each of the tools don't have the context, so we're adding the context to the tool. And so this is the prioritization engine that Max and I have come up with. So this is not the only way to do it. What we have done is that we are considering multiple factors that people have used in the industry and combine them together in a ways that makes sense to Greenlight, makes sense to what we're trying to protect. So we would start with a CVE, which is most of the time, like the tools would output like an issue with a particular CVE, meaning that it has like some sort of vulnerability that is acknowledged by the industry and the audience, in the industry. We also look into the CVSS, which most of the tools would produce as well. CVSS, as I'm sure that most of the people in the audience know, it's like a severity score for each of the issues. So it goes from critical, high, medium, low. We also take into consideration of EPSS score. So EPSS is something that is fairly new in the industry. This is complementary to CVSS. So EPSS is the is essentially like how likely it is for a particular vulnerability to be exploited in the wild today. So the score change every day. Every day it has a different score. So today it might be like 10%, tomorrow it might be like 12%, things like that. So so we're using CVSS and EPSS to get like an initial score. We're also looking into exploitability. So as Max was mentioning, we're using Oligo to run like the runtime analysis for our SCA. Exploitability in here, it means more like reachability. Is there a path to reach it through our code? So we're using Oligo to help with this. We're also taking into consideration whether the issue is existing in an internal service or external facing service. We also look at things like CSACF, which is the category of exploited vulnerabilities that are managed by the US government. We're also looking at whether the issue has a fix or not. Essentially, what this means is that, is the issue actionable today, or is it something that we need to continue to monitor in the future, and then and then come up with like an action item that is appropriate for that particular issue. And so at Greenlight, we are combining all of these factors in order to get to a severity that makes sense for our company. And not every single tool has all of these factors. So if it's missing any of the factors that we're having on the engine here, we just skip to the next one because we realize that that would be the most conservative way, and it's better to be more conservative, safe.
All right.
So I just want to talk a little bit about CVSS and EPSS. Because I feel like CVSS has been very well known. A lot of companies are using it. EPSS is a factor that Max and I recently considered into like our prioritization engine, and we found it really helpful. So CVSS is like the severity. EPSS is more like the probability of like being exploited. So I want to draw like an analogy. I think that most people can relate to is that for a penetration test, whenever they find some issue in your application, the severity normally derives from, like the impact and the likelihood, right? So I think this kind of like parallel to that. CVSS is kind of like the impact, like how much damage can you do with this particular issue. And when you look at CVSS, right, you're looking at like scope, you're looking at CIA, like the confidentiality, integrity, availability. So it's more on the impact side. Versus EPSS, like it measures the probability of like being exploited in the wild. So this is more like how likely it is. So combining CVSS and EPSS, it gives a clearer picture of like how important that issue is to the organization. And the graph and the numbers you are seeing in here is essentially, like from the first.org site. This is not the data from Greenlight, but just to show you like how you can narrow down the scope with both of the scores.
Okay, great. And then so are both of these considered like roughly equal? Like if one is 50%, this is not how it worked out, but one would be like 50% of the score, the other would be 50% of the score, or they're both like equally weighted in that diagram?
Yeah, so in the Greenlight system, they're equally graded. And so in the next slide, like you can see more onto like how we are grading it. So essentially we have like a two-dimensional EPSS, CVSS. So CVSS would go from like critical, high, medium, and low. And then EPSS, this range is like completely arbitrary. This is not actually what we're using at Greenlight, but just to give you like an example, and you can look more onto like their website in terms of like the percentile bins for the EPSS to determine like which range that you would want to segment like the score from 0 to 100. So for example, in here, right, if the CVSS score is from 9 to 10, which means it is critical, and the EPSS, the likelihood of exploiting it is more than 50%, and it is critical, then you might think, okay, this is like really critical, like it needs to be fixed as of today. Or, if you have like something that is CVSS score between 4 and 6.9, which is a critical height medium, with an EPSS score between 10 and 50%, you might think that, okay, combining the two, medium and, like upper one, it might be a low. So depending on, your company risk tolerant, you might want to section the EPSS score appropriately to your company.
And then one thing to highlight is that this is used specifically for a lot of the SCA findings, but this is our initial prioritization. So it doesn't this is before we have reachability as a factor, or internal, external exploitation, or accessibility as a factor as well.
Right. So you start with this and then you add on those factors to get your final score.
Exactly. Yeah.
Yeah.
Yep. Yeah. Great. Okay. Do you want to talk a little bit about, what kind of savings have you guys seen and value that you've seen from automating?
Yeah, so we save a lot of time with Tines by having Tines doing the work for us. So we save roughly like 30 hours every week, with Tines. So that is great. Next one is no manual triage at all, because we are writing the rules and automation to Tines, so that Tine is doing all the manual work for us. So interchangeable tools, right? So as you can see, we have a prioritization engine, and once we have that established, like just swapping tools in and out is very easy. It would have taken us like 3+ months to swapping a tool in and out, and now it would take us 2 weeks, and that 2 weeks is a lot of like testing, making sure that the tool is performing as expected with our system. It reduced a lot of onboarding time for a new security person to come in. We can just show them, this is how we are doing our vulnerability management program. Here's how you can make changes. And so it's very easy. And last but not least, right, like once we save that 30 hours, we can spend the time on building more defenses and building more programs that would help secure our product more. So a lot of great values from Tines.
So, quick question before we go on. On the tools, you mentioned saving, like bringing a new one on from 2 to 3 months to a couple of weeks. On average, how many tools do you guys, look at adding in a given quarter or year?
So there isn't a number like a specific number that we're looking at every quarter or every year, but every quarter we do evaluate the tools, whether it's still meeting our expectation, whether it's still meeting our plan and our vision for the program. And if it does not, then we would be looking into a new tool.
Okay, great. Well, that brings us to the end of the prepared remarks. We've got a couple of minutes left for questions, and we've got one that came in. So I'll throw it out, and Max, you or June can decide who to answer. So what sort of data aggregation tools were you using before Tines to kind of like bring this vulnerability sources together, or were they just managed separately in silos?
Yeah, I can take that one. So when we were first doing things, it was awful. we were doing things separately in silos depending on the tool that it was, and then the next option we had was that we had a Google Sheets API that just stored everything, and that was horrible too. And then so as we started to look into it, right, the next option is, okay, we'd have to build a local database to actually store this information, or we'd have to store it somewhere. Or maybe we'd have to leverage another source of truth. All of that just became really complicated when all we wanted to do was check whether or not that finding still exists or not. So that's kind of part of one of the reasons why we moved over to this.
Okay, great. Another question that came in, how have you approached Dependabot findings and automation around that?
Yeah, I can take that question. So we actually used to have Dependabot as well, and as Max mentioned, right, like a large volumes of the SCA issues that are found in Dependabot, which is essentially like kind of helping us like to like hone down our prioritization engine, because at this point, right, what Dependabot is giving us is the CVSS score, what is the severity, like what is the impact, but it does not have the context into how does this apply to our organization. So this is when we really start looking into other things like EPSF score, whether it's internal, external, whether it's reachable or not, among other factors. And so once you have that hash down, just kind of like type it away in Tines and have Tines doing the work for us.
Yeah, then to add a little bit to the Dependabot things, mainly because we have a lot of opinions on SCA, and I think for us, like when you're trying to make progress on SCA, SCA seems to be a common area for focus for a lot of security teams, because for those who are trying to communicate, understanding and value to organizations, SCA is one of the easiest ones because you have a clear picture as to what is a problem, right? But then adding that context to it is where kind of we find challenges. So in order to enrich it, one of our big focuses has been to look for reachability analysis. There are, of course, enterprise tools you can use for it, but there are also open source tools that can help you with that as well. Just might take a little bit more legwork.
Yep. Okay. I think we have time for maybe one more question that's come in. What was your team's time to respond before implementing Tines, and how has that improved now?
Yeah, I can take that one. For time to respond previously, when it comes to specifically, some sort of vulnerability, I'll give you an example. It's like when for Log4j that happened a little while ago. That was definitely a mess for us because that was a pre-Tine situation for us. We had to go through all of our input sources to see, what actually had that issue. I think it took us almost. We still kind of full hands on deck scramble situation. I think it took us about 2 days to get through all of that, which is, a heroic effort from everybody on our engineering department to work through that, right? But that we couldn't handle having to deal with another fire. Like that's just not something we wanted to work through again. So immediately we were looking for ways that we can automate. And then now on a daily basis, any new input sources or any new vulnerabilities that pop up that could be potentially a log4j situation, we would have covered at least from an identification standpoint within that day. Or we could run it immediately once we hear news or an article comes out.
Yep. Awesome. So last question, I'm just curious, with the vulnerability lifecycle process that you guys have put together, it's, so hands off. What's your next automation project on your list?
Yeah, I can take that. So even though the process is completely hands off, it's not like we're not, coming back to it to make sure that things are still running smoothly, that we're improving, our processes and making sure that, our tools are still sending with the values and the direction that we want to build the team toward, right? So like that maintenance and improvement work is always there. One of the projects that we're looking to expand to in terms of automation is that now that we have the SCA, the SAS, and the secret scanning pretty much there, we can look into something that is more advanced, like the CI/CD pipeline scanning, image scanning. And so once we have that built out, we can also automate that process to making sure that we're scanning like our entire product security domain and making sure that we have as little gaps as we can.
Awesome. Great. Well, I'm sure your Tyne CSC would be happy to help with that project and getting that one going too. So anyway, thank you everyone for joining the call today and all the great questions. Max, June, thank you so much for sharing your insights and the Greenlight story with all of us. Just a quick reminder to everyone, we'll be sending out the recording tomorrow. So keep an eye out for that in your inbox. And then also, remember, this is the first in our series of new Tech Talk webinars, and we'll be coming out with another one next month. Stay tuned for next month's session, which will be around AI in Tynes. So thank you, everyone.
Thanks for joining.
Thank you.